You have already seen the things that tank is applied in maybe in daily life to determine some things, maybe to determine the height of a building without measuring the building and get the height of that building, to determine the distance from the earth to the sun. You don't have to measure that distance, but at least you can maybe use trigonometry and get the value. Even very tall buildings like skyscrapers, so they use mathematics. You don't need to get a tape measure and then you start measuring the building from the foot to the top. If they find you, they may think that you're mad. So it's all about the mathematics. You have seen surveyors having these things. They have those gadgets that they use, and sometimes they are noting down something, sometimes they are even calculating some things. So this is one of the applications. This is one of the things that we use in those applications of survey of anything that is concerned with measurement. So under application of tangents, we have the elevation and the depression. So what is elevation? Whenever you stretch your head and try to look up, it means that your eyes are getting elevated to a certain angle. So if you are looking at something which is above, we call that elevation. So you are being elevated at a certain angle to the horizontal. And you should know that if this is the horizontal and this is the particle that you are looking at, particle P, then it means that your eyes are being elevated. So the angle is normally measured to the measured to the horizontal. And then if you are looking at depression, you are trying to look at something which is down. So maybe you are at the top of the building and you are trying to look at something which is down. So that angle at which you are being elevated, at which you are looking at something from the top to the bottom, that angle is what we call the angle of depression, and it is also measured from the horizontal, and then you measure. So that angle is this letter. You are seeing a letter beta or B, but it's beta. Alright, so you can have maybe someone at the cliff, is standing at the cliff and is viewing the boat or the ship. So that person will be viewing the ship at an angle of depression beta, because he's at the top looking down. So looking down, that's depression. So looking down, that is depression. And then someone who is on the ship and is trying to look at someone who's at the top of the cliff, that person, his eyes will be elevated. Will elevate his eyes so that can see the person at the cliff. So the person at the ship will look at that person on the cliff at an angle of elevation. So the angle of elevation, which is alpha, this letter here which appears as A, is alpha. So we are going to look at some of the examples here, and then we shall proceed other things. So we have example 12.6. So they are talking about a boy. They're saying a boy, and what's wrong with that boy? The boy is 120 centimeters tall. The boy is 120 centimeters tall, is standing 50 meters from a flag post on the ground. He finds that the angle of elevation to the top. So what is he trying to do? He's trying to look at the flag post. So he's down and he's looking at the flag post which is up. So he's elevating his eyes to look at the flag post which is up. So it means that it must be at an angle of elevation. So he finds that the angle of elevation to the top of the flag post is 15 degrees. Then calculate the height of the post. Calculate the height of the post. So to show you that clearly here, what you are supposed to do is that, okay, so let us see if this is the flag post, the way it is drawn there. This is the flag post, yeah, and that is the flag. Okay, that's the flag, and this is the ground. This is the ground, and they have told you that this boy is, maybe this is the boy here. That's the boy. So that is the boy, and the boy is looking at the flag post. So from, let's say, from his eyes here, that's where his eyes are. So he's looking at the flag post. Okay, there. So the angle of elevation is always measured from the horizontal. So that is the horizontal. So I'll draw the horizontal with dotted lines to there. So if this boy is, they have said the boy is 120 centimeters. So we know if this distance is 120 centimeters, so it means that also this distance here from here up here to be 120 centimeters. 120 centimeters. Okay, so now the angle of elevation is 15 degrees. So what are they asking for? They're asking for the height of the flagpole, the height of the flag post. They're asking for that height. So what we are, let me call it capital H. So what we are going to do is, we are going to first get this distance here, which is here. We call it small h. We get that small h and we add it to this, we shall be able to get the capital H, which is the height of the flag post. So to do that, I will extract out this straight angled triangle here, which is here, and I'll come and draw it. So I have this triangle. So I have 15 degrees, and I know this is H. So what is the distance from the boy to the flag post? The distance from the boy to the flag post, they say the boy is standing 50 meters. It is 50 meters. So I come and write 50 meters here. Now I need to find H. So there, that's where I should apply the trigonometry or the tangent. And I'll have tan of 15 equals to the opposite, which is H, out of the adjacent, which is 15. So to find H, I'm going to cross multiply and I'll have my H equals to 50 times tan 15. So my H becomes, Cynthia, what's the answer? You don't have a calculator, you know? But let me see who has a calculator here. Patricia, what's the answer? Patricia, what's the answer? Patricia, are you there? Unmute, I'm not getting you. People, no one who has a calculator. People get serious. Anyone who knows the answer? Treasure, what's the answer? Yes, Maya, what's the answer? Yes, it is.
It is 13 point.
13 point what?
13.3975.
13.3975. So you can say 13.3975. So you can round off and say 13.4 meters. So after finding h, thank you very much, my after finding h, then what we are supposed to do is we can get let me zoom in here a bit and you see. So what we are going to do is to find this capital H, we are going to say h plus 120. So these are meters. Why are they meters? Because we used 50 meters here. 50 meters. So 50 meters are the ones which are in our calculation here. So it means that this is 13.4 centimeters. So we are going to add 13.4 meters. We are going to first convert it to centimeters and we shall add it to 120 centimeters for us to get the total H. So it means that our H here becomes 13.4 times 100 to have it in centimeters. So what do we get there? So we get H is equal to 1304 centimeters. So to get capital H, you can say now H is equal to the small h, which is 134 altogether, then plus 120. And what do we get from there? Esther, are you there? Esther, simple mathematics. So you get.
Yes, teacher.
What's the answer?
13,000.
Yeah?
13,000.
Are you sure? 1,340 plus 120?
1,460.
1,460, which can be 1.14.6 meters. Okay. All right, any question? I don't think so. So let us do, we are going to do one more question. We are left with only 5 minutes. Yeah, it will only 5 minutes. 5 minutes. So we should do at least one more question, and then the next, when we come back, we shall start with a sign. Okay. Let us look at number 4, the exercise number 4, this question here, number 4. They are saying that a vertical tower 40 meters tall casts a shadow on the level ground. So they are saying that a vertical tower 40 meters tall casts a shadow on a level ground. Calculate the angle the rays of the sun make with the ground. Okay, so it means that there is a certain tower that is 40 meters tall. So if this is the tower, 40 meters tall, okay, this is the ground. That tower casts a shadow on a level ground. Calculate the angle the rays of the sun make with the ground. Okay, so if there is the sun, so that sun is going to make this building to cast a shadow on the ground. So the shadow of the ground is also going to be 40 meters. So suppose this is the shadow and the ground. So this is 40 meters, and this is the shadow here and the ground. So they are rays from the sun. So if the rays are like that, so expect the rays to come like that. So this is 90 degrees there. So if this is 40, expect also this to be 40. So they're asking you to find this angle here. That's the rays, the angle the rays make, the angle that the rays make with the ground. So they want us to get that. They want us to get that angle. So this is the shadow down, and this is the building. So we can say that tan theta equals to 40 out of 40. Okay. So this is 1. So theta equals to the tan inverse of 1, and theta equals to tan inverse of 1 is tan inverse of 1 is, so come and press it here, shift tan inverse, I say shift tan inverse of 1 and press equals, you get 45. So the angle is 45. Any question, members? Any question? But
Yes, teacher.
No,
do you have any question,
teacher.
member?
Yes, teacher.
Yes.
Teacher.
Yes, Patricia. The one you're not.
Circumstance. We use that tan inverse.
Sorry. Under what circumstance do you? Under what circumstance?
Okay.
Okay. But Patricia,
Teacher.
Patricia, I've had your question. I've had your question. You were asking
I was asking.
under what circumstance do we use tan inverse? We use tan inverse if we are finding the angle. Are we together? If you are finding the angle, that's when you use the tan inverse. Any other question?
Yes, teacher.
Yes, Esther. Esther?
She was asking that why do we only use tan in. She was asking that why do we only use tan instead of cos or sin?
Okay, we are using tan because in the chapter that we are looking at, we are still looking at tangents. Are we together? But afterwards, we are going to look at cosine and sine. Is it okay? Alright, so alright, so this lesson is going to end in the next 40 seconds. So you go back and click on the join button as we have a break of just 2 minutes.
Okay.
Yeah.